Hello students, welcome to the next module of the chapter, and in this module we are going to learn about MCQs on definition of surface tension. Now let us go through the very first question, and that is a wooden stick 2 meter long is floating on the surface of water. The surface tension of the water is given to us as 0.07 newtons per meter. By putting soap on one side of the stick, the surface tension of water is reduced to 0.06 newtons per meter. What is the net force on the stick? And the four options are given to us as 0.06, 0.01, 0.02 and 0.07. Now class, if I were to elaborate the entire diagram, it would be something as shown. Now class, you have a container. Inside the container you have liquid, and on the top of the liquid you have kept a small wooden stick. Now from the diagram itself is clear that the weight of the wooden stick is balanced by the surface tension force. Now when you put some soap on one side of the film, as you can see on the diagram, that upper side of the wooden stick has shown with the color of blue. That means on that side I put some soap solution. Now class, in the previous module we have learned that whenever you put some contamination on the liquid, the surface tension decreases, right? So that's what the question is saying, that by putting soap on one side of the stick, the surface tension of the water is reduced to 0.06 newtons per meter. What is the net force acting on the stick? Now, since initially the liquid on the left and on the right was same, the force was F and F both the side. But this time, the liquid on the upper side of the wooden stick is different, and the liquid on the lower side of the liquid is the liquid on the lower side of the stick is different, and hence the surface tension force provided by both the types of liquid is different. So I have shown that force as F1 and F2. Now I know that weight of the wooden stick is balanced by the surface tension force, which is nothing but F2 minus F1. So I know that F is equal to TL. So that means F2 would become T2 into L, and F1 will become T1 into L. So if I take L common, F2 minus F1 would be T2 minus T1 into L. Now if I substitute the values, T2 is given to us as 0.07, T1 is given to us as 0.06, and L is given to us as 2 meter long. Now if I solve it further, I get 0.01 into 2, which is nothing but 0.02 newtons. So the correct answer is option C. Now moving to the second question. The second question says that a metallic wire of length capital L and density D floats horizontally on the surface of water. What should be the maximum radius of the wire so that the wire will not sink in water? And the four options are given to us as R is equal to under root of T upon pi dg. Option B says that R is equal to under root of pi dg upon 2t. Option number C says that under root of 2t upon pi times d into g. And option D says that R is equal to under root of 2 dg upon pi times t. Now, if we talk about the solution, I can say that upward force due to surface tension is equal to downward force due to weight, and only when this equation is satisfied, the things will be able to float because of surface tension. So that means upward force because of surface tension has to be equal to downward force because of weight. Now class, the upward force because of surface tension, that is F, is equal to T into L into 2, because the wire is getting pulled by the free surface from both the sides. So I have 2 into T into L is equal to downward force because of weight, that is weight is equal to mg, mass is equal to volume into density. So I replace m by V into D, and I replace V by area into length. Area of the wire is pi r square, and length of the wire is given as capital L. So I say that 2 into T into L is equal to mg is equal to V times D into G is equal to pi r square into capital L into D into G. Now class, I have total 4 values, and out of which if I compare the first and the last value, I have 2 into T into L is equal to pi r square L D into G. Now here L and L gets cancelled, so I have r square is equal to 2 times T upon pi times D into G. That is nothing but R is equal to under root of 2T upon pi dg. So this is nothing but option C. I hope you have understood the module class. See you in the next module. Thank you.